Hello, I'm Ernest Murray and I'm a Senior Scientist at LASA Limited. I currently work on Meteor Nexus and the development of new biotransformations and updating existing ones. This presentation is a short introduction to mass defect filtering, which is a key feature of Meteor Nexus. Here we have a table of common elements observed in pharmaceutical compounds. The term mass defect originates from the fact that only carbon-12 has an integer value for its atomic weight, and in this case 12.00000. Here the term mass defect refers to the difference between the exact mass of an element or compound and its integer value. This value can be positive, as is the case for nitrogen, or negative, as in the case of oxygen. Quetiapine, also known as Seroquel, is a short-acting atypical antipsychotic drug which is used for the treatment of schizophrenia, bipolar disorder and depression. To calculate the mass defect of quetiapine, we subtract the nominal mass of the structure from the exact mass. So, in this case, the exact mass is 383.16675 and the nominal mass is 383. Therefore, the mass defect is 0.16675. One of the known active metabolites of quetiapine is 7-hydroxyquetiapine. This metabolite is formed in the liver, and the enzymes responsible for this biotransformation are CYP3A4 and 2D6. The reference for this information is shown at the bottom right-hand side of this slide. The respective exact mass and nominal mass for this metabolite are calculated as shown. The mass defect of the active metabolite is therefore 0.16166. Subtracting the mass defect value of the active metabolite from the parent compound gives the mass defect shift value. The calculated mass defect shift value of the active metabolite is minus 0.00509. Notice that in this table we have seen this value previously for oxygen in the mass defect column on the right hand side of this table. So, back to the active metabolite. How can we use this value of minus 0.00509 in Meteor Nexus? Let's process quetiapine in Meteor Nexus. First, we can draw the structure or copy and paste the SMILE string. Go to Meteor Prediction Setup, and in the settings we'll leave on Phase 1 and Phase 2 biotransformations. We changed the maximum depth to 1. The minimum likelihood remains at equivocal, and the maximum number of metabolites remains at its default value of 1000. And then start prediction. The reason for using the given processing constraints are just for illustrative purposes, and therefore we will not be predicting second or third generation metabolites. Here we see that there are 28 first generation metabolites predicted. If the settings were left at the default values, then there would have been more metabolites predicted, including second and third generation metabolites. So, if we select the Filters tab and scroll down to Query Mass Defect, and we enter the absolute value of 0.00509, this is the value that we calculated earlier in the presentation. Press the tick. In general, using this value will filter the results so that metabolites which have undergone hydroxylation, epoxidation, or S or N oxidation will be displayed. As we can see from the results, the tree has been reduced to only 11 metabolites. And here we see the active metabolite 7-hydroxyquetiapine, which has been predicted. Another use of mass defect shift value is to distinguish between metabolites that have increased in mass by the same amount but have arisen by different metabolic pathways. In this example, both metabolites have increased in mass by +16. However, the compound on the right has undergone carboaromatic hydroxylation, whilst the one on the left has undergone two biotransformations, carbonyl reduction and N-methylation. As you can see from the calculated mass defect shift values for the metabolites, they are very different, hence an alternative method for filtering predicted metabolic trees created by Meteor Nexus. This table shows other mass defect shift values which can be used to filter for other types of biotransformations. Some examples of Phase 1 mass defect values are given in this table. For dehalogenation, hydrolysis and Phase 2 conjugation tables of mass defect values, these can be found in the paper by Zhang. If there are any other features of Meteor Nexus or any other LASA products that you would like to see demonstrated, then please get in touch. Visit our website for further details. Thank you for listening.